How do you treble reserves? By redeveloping an abandoned oil field. Today we're going to look how Donan became Dumbarton. So there have been several publications in the scientific literature featuring a variety of former colleagues. Today we want to look at what unlocked the potential. What was the root reason for why Dumbarton got unlocked and were able to come back in and actually redevelop an oil field with a great success. Donan started life as a discovery by BP back in 1987. First oil from two vertical producers was back in 1992, and it was actually developed on 2D seismic. It was only in 1993 that BP shot a regional 3D. 1997, production ceased, and we'll talk about that. It was actually this vessel here on the left, the Seillean, that actually produced the oil in what's called swaps. We'll come on to that. Then Kerr-McGee acquired the acreage back in 2002, a series of deals that actually brought that about. And then in 2003, they reprocessed the old 3D data. Liked it so much, went ahead and actually acquired new 3D data, PSTM processing, and in 2005, they sanctioned the redevelopment of the Donan field as Dumbarton. This time using this vessel here, Global Producer 3. The second oil, as we call it, which was in 2007. That involved 5 horizontal producers and a produced water reinjection well. And here in 2024, when we record this video, well, the field is still going. Seillean, by the way, that's now just scrap metal. Here was Donan, and you can see the lower Balmoral sands. This is the top here, around about 6,375 feet, 6,400 feet. Within these sands here, good quality sands, perforated the top zones. Now, you can see the parameters there. The Seillean, the ship in the previous slide, it was called SWAPS, Single Well Oil Production System, and it was operated by BP. But in actual fact, it was 2 wells, so it was really TWOPS, not SWAPS. The vessel and the production facility, it had no artificial lift. It had neither gas lift nor any electrical submersible pump capability, and so as the water cut increased over the life of the field, the gross rate fell away at a time when the oil price was low as well. And following an unsuccessful drilling campaign, the SWAPS experiment was terminated and Donan was abandoned. So we always like to go back to basics and talk about how oil fields work. And you can see here we've got a vertical producer and a horizontal producer. And here's our top reservoir here. This is a cross section. Here's our oil reservoir. The oil water contact is this blue line. And underneath that we've got the aquifer. The advantage of vertical producers, well, they're very relatively cheap, easy to drill, but what you do get is you get a localized pressure drawdown, and it actually can cause the water to be cone up in towards the well because the pressure differential. And you leads to sort of higher water cut wells earlier in the production history. That's the vertical producer. The horizontal producer, well, that kind of distributes the drawdown, the pressure drawdown as you're kind of pulling on the reservoir. It maximizes the offset, so that's the distance from the well down to where the water starts here below the oil water contact. And there may be a little coning, but it's more kind of spread out. It's less dramatic, and it means that there's lower water cut for longer, and hence you get longer life wells. What actually happens is you actually geosteer these wells and actually keep it as close to the roof as you can. And that actually maximizes the offset. I always think it's always good to have a great interview question for your graduate geologists and your graduate engineers. I like this one. Why do wells flow? Well, the answer, oil flows because the pressure of the oil in the reservoir is higher than the pressure of the oil in the wellbore. So oil flows into the well. But it's not only that, it's the bottom of the well is at a higher pressure than the top of the well, or in this case, or in most cases, it's the first stage separator, which would be on the FPSO, on the Global Producer 3 at Dumbarton. Thereby, oil flows into the well, and then oil flows to the surface facilities. Now, when the pressure drops within the reservoir, if it equalizes the bottom hole pressure, then the well stops flowing. There you go. There's a good interview question for you. Now, there are two primary controls. The fluid offtake, you're basically taking material mass out from the reservoir, and you're kind of leaving a hole behind, a voidage, and it's not actually a hole, but you're actually lowering the pressure, and you're taking out some of the materials, so it lowers the reservoir pressure. If you've got an active aquifer which is coming in and supporting that production, or if you're using water injection, you can offset that fluid offtake and kind of balance the voidage replacement, as it's known. The other way of doing it is you can just lower the effective bottom hole pressure, and that's why we use electrical submersible pumps, jet pumps and gas lift, etc., that sort of artificially lowers the pressure down at the bottom of the well, and it allows the oil to flow in, and then of course the oil is kind of preferentially moved up the string there towards the production vessel. So as water cut increases over time, the effective density of liquid in the well causes a sort of a back pressure on that reservoir interface, and that's why the oil slows and actually in time will cease flowing as the back pressure starts to equalize the near wellbore reservoir pressure. So this is what Donan field looked like. There were two wells. There were these white stars are here. It was seen as being quite a small little field with the two wells merrily producing away. Produced 15.3 million barrels between 93 and 1997. But then when we look at it here, and here is the 6 well, here is the 4 well, you can see initially developed on 2D, but when the 3D came along, you could see that there was this patchy indications of oil response on seismic. We'll go into that in a little more detail. These 2 wells, then there was a campaign of wells drilled in here, which were really not very successful. They didn't find very much sand, although it looked like there was a good oil signature. They didn't actually find very much sand in those regions. What then happened was the original map from the operator was this blue outline here, whereas the purple, it was actually the remap with the aid of 3D and a lot of thought. We'll talk about that in a little more detail. You can see that the field really grew both aerially and volumetrically. So then what happened was there was this was the drill center here. And there was a 5 horizontal well developments here. There's shown. There's D1, here's D5, D2, D2Z, D4. Interestingly, actually, is that this well here was the only one that wasn't very successful. It didn't find very much sand in the same area where the previous operator had tried to find sand, and we didn't land out a particularly good well there. So what we did was we actually went up to the north, sidetracked it here, made a really good well out of D2Z. These are the appraisal wells drilled and highlighted. I wanted to talk about the number 15 wells. So this 13 well, it found what was a satellite development, which we'll talk about a little bit later. 14 really was kind of within the area of the old field, so it didn't really add very much to the party. 15 was the well that I came on board as the subsurface manager for the team, just as we were planning to further appraise the field. And there was a debate as to whether we should drill the 15 well here or another location up to the northeast. We'll talk about that in a little while. But this was another well, just to really see, where was the up-dip limit to this field, because it wasn't obvious where the field ended. So the 15 well, there was a dawning realization at the time that Donan was on the margin of a major chromaty sand fairway. There was evidence from that from fields like McCulloch and regional mapping and some detailed biostratigraphic zonation. Now, there were a number of wells, you can see them all listed here, and typically, prior to the drilling of the 15 well, there was a net to gross range around about 0.3 to 0.7. So if you look at this on some sort of Gaussian distribution, normal distribution, you can see, sort of 0.3, 0.7. And the suggestion here is that because net to gross only goes from 0, it's all shale, to 1, it's all sand, that there's a very, very low probability density function or frequency. Actually, this is where the 15 well came in. It actually came out with 100% sand in the upper section, and that's the upper section is the one that really counts. It's where the oil makes its way to the top of a very, very thick Paleocene sand sequence. So this is where you want the sand to be developed. This wouldn't have been an appropriate distribution to put in if you were doing your volumetric assessment for the 15 well. Here again is the information. This was from a Paul Middleton paper, and kind of don't understand one of the wells there, so this is a slightly modified version of it, taking out the 12 well. These are the sands, thin sands with lots of shale in the section. There's the line of the section here, joining up all the sands as you run across the field. Not a huge amount of sand. From that, would you have predicted that in the first 50 metres that you would have all sand from top to bottom? That's what the 15 well found. And there it is, the 15 well. Once that was successfully drilled, that was really the field development was assured, and we could move forward with FID and get the field up and running. That's the story of how Donan became Dumbarton. Again, we've talked about, I think BP were unlucky in that region. It just seems to be a sand poor area of the field. The D2 well didn't really do very well either. I want to talk now a little bit about this seismic response. This is not going to be a very, very detailed analysis of seismic and DHIs and AVOs, etc. This is kind of illustrative and it's simplified. I'm not going to be doing a full technical description. We want this to be understood by more viewers than just a handful of specialist geoscientists. Where you have a seismic response as you go from shale into the sandstone, if those sands are oil bearing, you tend to get a peak. If you go from the shale into the sands, then you get a trough. A trough is where the sands are water bearing, and a peak is where the sands are oil bearing. Now, obviously, at some point, as you approach the oil-water contact, there's going to be a very, very thin oil column, and you've got to go between a peak and a trough. And if you go from a peak to a trough, you come to what we call the zero crossing. Basically, there's no peak, there's no trough there at all. The more correct answer is to start talking about acoustic impedance, AVO, DHIs, Poisson's ratios, and changing through time with production as fluid substitution goes on. We should be talking about, in the case of Dumbarton, overburden anisotropy, which I'm not going to go into. And we can also talk about the changes with fluid replacement, the 4D effect. We're trying to keep this simple, so bear with us. So here is a seismic line. If you imagine, here we are auto-picking, and here is what we are picking as the top of our reservoir. And we pick this peak off the flanks here, up over the structure of the reservoir, and down on this peak. Now, that's one interpretation. Or we could actually follow this black peak down here. Maybe that's a more likely candidate for how it goes. That's what, maybe you could envisage an auto picker going for. Now, in this lower section here, what we're trying to illustrate is that from the Earth physics, that off the field, the response is actually a trough. Probably is the trough above, but again, this is for illustration. So you follow this trough. At some point, you come to a zero crossing where it's neither one nor the other, but then you have to get onto this peak, and then you follow the peak here all the way off, and then you drop back onto another trough, and you follow the trough. If you were to show this line to an exploration committee a few years ago, when I started out in this industry, you'd have been fired for actually having the audacity to actually go from a trough to a peak back to a trough. It makes absolutely no sense. But the Earth physics says that's what it should be. Again, I'm simplifying this. There are some complexities. It is worth pointing out, though, that on this section here, this is the interpretation that was made. They've gone right through this trough, through this red trough here, stayed on the trough right through the field, and gone back and stayed on a trough outside. So that actually makes no sense, but there you go. This is what an auto picker might do. It might pick the yellow surface up there, but equally from our interpretation, we've followed both the peak over the oil field and the trough off the oil field. And if we kind of move them up, you can see this is how they overlay. In this scenario here, you've basically made the field a little bit higher relief, but you've also made it a little bit smaller because it's dipping down on the flanks a lot steeper. But the reality is probably more like what happens on this side, and that is that because you're picking from a peak and then you're going on to a trough, you actually keep the size of the field higher, structurally higher for a greater area. And hence you really vastly improve the volumetrics. Again, the full answer includes some of those. We're not even going to go there. This is an example of why I don't think that artificial intelligence is going to replace geoscientists for a very, very long time. You have to understand that Earth physics model that, a peak is oil, a trough is water, and you have to jump from one to the other if you're going to map this field. And I wonder how many of these there are on the old data. On the old seismic, there's warehouses full of seismic where you don't have the benefit of these long offset seismics, so you can't do your AVOs, you can't really see your DHIs. Maybe you've just got a relative impedance or a wrap section, we used to call them. You don't really have information on all these rock properties. So I'm talking about going back to oil fields that maybe from the 40s, 50s, 60s, 70s, which really predate any of this. Are there opportunities that have been missed, like Dumbarton? A field that was abandoned. Global Producer 3 was redeployed from Leiden. The Leiden field featured in our 10 worst UK oil fields video. If you haven't seen that, it's quite a good laugh. Well, I was lucky enough to actually visit the vessel when it was in dry dock. And you can see big vessel, 150,000 barrels of total fluid, 90,000 barrels of oil processing capacity, and a lot of gas compression capacity, 70 million standard cubic feet of gas a day. That's the vessel. Great vessel. Here's the vessel anchored down. Here's the various flow lines here running off to the drill centre where there's a manifold, and then you see all the different individual wellheads, those 5 producers and this produced water reinjection well. Horizontal wells. It was Maersk Oil, but it was Kerr-McGee, became Maersk Oil, became Total Energies, and I think now is with Neo. Here we've got the proof of the pudding. Now on the slide, I can't find the latest production data, more on that in a second, and there was no scale on the original, so you can see here, but I know that it kind of peaked at around about 45,000 barrels of oil per day. So this was Dumbarton coming on stream here, and of course in time found the nearby field, the Loch Ranza, which was another very thin oil column that was tied back, and then Balloch actually underlay Dumbarton field, and it was up in the Jurassic Piper sands. So you see, success brings on additional opportunities, and so the profile got stacked. But Dumbarton alone has produced over 50 million barrels of oil on its own. When we go into the NSTA production data, I don't know what's happening there, but you don't seem to be able to find the fields these days. You can actually find them if you actually follow the Power BI, and that's the link at the bottom there. And we'll put that in the description below, so you can have a look at that. Most of the links won't get you to the PPRS data these days. I don't know what's gone wrong there, but hopefully somebody will look into it and put some of those links back in place as they should be. What we can find out here is, with a lot of manipulation, you can find the data. This is well, they call it Donan Maersk. It was actually, should have been called Dumbarton, but for some bureaucratic reason, it was called Donan Maersk, which it's still called. And of course, Maersk have not been involved in it for quite some time now. The colour schemes in here leave a lot to be desired. I won't say much about that. But blue is oil. Yeah, there you go, who'd have thought. And this is brown is total hydrocarbon. So very often the brown overlays the dark blue and you can't actually see it. So that's the oil profile. Gas is this thing in green here. That doesn't make much sense, does it? Or water in red. This now is when you actually look, and we've tried to highlight just the oil curve here. Now, this was Donan back here, and of course somebody hasn't put in a 0 to take it down to the bottom line, or a 0 to where it actually starts again, so you get this thing, but that's fine, that's just an artifact. But you can see this was Donan. This is all Dumbarton. It's actually Dumbarton with the other fields in there, with Loch Ranza and Balloch as well. You can see the difference. Donan was a small field. Dumbarton has been a major success, and I think in total it's produced somewhere in the region of 60 odd million barrels of oil. Now this is kind of interesting as well. This is one of the consultancies, they've actually taken the Dumbarton and they use annualized production data, and they show it here from 2007 projected out to 2028 annualized averages. But because of the confusion, possibly because of the confusion of colours on the website, they actually label it as mainly being natural gas production, with only a tiny small amount of crude oil and condensate. And given the colour schemes, you can very well understand why there is such confusion. So hey ho, maybe Petrogas would like to send us an up-to-date profile, and we'll publish it on an update in the future. What have we learned? Well, Donan ceased production at 15.3 million barrels. Dumbarton redevelopment, well, that's produced an additional 50 million. So in total, over 65 million barrels has been produced from this Balmoral Sand Paleocene reservoir, good quality reservoir. So the Earth physics has to be recognised by the geophysicists. There is a fundamental difference. You have to understand what the configuration of oil in sands is actually going to result in. It's easily done with modern seismic and all the techniques, but with older seismic, full stack, short offset, low fold data, 2D data, how many of these fields are actually sitting out there that we haven't really had a chance to look at again? So, lovely article recently in the excellent GeoExpro magazine, which talks about a warehouse full of old seismic tapes. I wonder how many fields like Dumbarton are sitting on those tapes and have been missed. Tough decisions have to be managed. When I came in on the number 15 well, it was actually it was our team that wanted to drill the northern location and the partners who wanted to drill the southern location. It all worked out at the end of the day. Was it luck we found such great quality sands, or was it kind of thinking out of the box and looking at the regional picture? I'll let you decide. And success breeds success. You know, once Dumbarton was up and running and established as being a much larger oil field, then along came satellites like Loch Ranza and a deepening of the wells to actually uncover the Jurassic Balloch discovery. I wonder, is there another chapter to be written? Watch this space. So these are the people there you can see I was involved really from the appraisal right through to first oil and left immediately afterwards, which is why my name doesn't appear on any of the scientific publications. And I do apologise to everybody who hasn't made it on here, but I've forgotten some of those names. I hope you found this talk interesting. If you've got any ideas for videos, more sort of how oil fields work type videos, we would like this to be a site where young professionals can go to for education and learnings, and for anybody who's seeking a career in oil and gas subsurface. If you've got an idea for a video, have a chat. Let's see if we can put something together. Now, TROVE videos are watched by tens of thousands of people worldwide. Those are the people in oil companies, in regulators, in supply chain companies, academics, all sorts. So if you want to get a message out and you want it to see a wide audience, consider putting it on TROVE News. Bye for now.